Hello students, let us solve one more problem on the length of the period 2L. Obtain the Fourier series of f of x. Here f of x is given, two functions are given, 2 in minus 2 less than x less than 0, and here it is x in 0 less than x less than 2. F of x is defined in the interval minus 2 to 2. Here you can see minus 2 to 2. This f of x is defined in the interval minus 2 to 2. Period of f of x, that is equals to 2 minus of minus 2 is equals to 4. That is 2L is equals to 4, L is equals to 2. Fourier series for the period 4 is given by f of x equals to a0 by 2 plus summation n equals to 1 to infinity en cos n pi x upon L plus summation n equals to 1 to infinity bn sin n pi x upon L. Okay, this is the Fourier series for the general length of the period 2L, and here our period length of the period is 4. Okay. Next we know that L is equals to 2. Substituting here, f of x equals to a0 by 2 plus summation n equals to 1 to infinity en cos n pi x upon 2 plus summation n equals to 1 to infinity bn sin n pi x upon 2. Let us take it as equation 1. Okay, since you can see here two functions are there, one is 2, second one is x. Okay, in the first function there is no x term, therefore you can't check the even and odd nature of the given f of x. Directly we'll solve the example, means we will find the Fourier series by finding all the coefficients, that is a0, an, bn. Now a0 is equals to 1 by L integration 0 to L f of x dx. That is 1 by 2, 0 to 2 x into dx. Why we have chosen x means here f of x equals to x in the interval 0, 2. 1 by 2 into bracket integration of x is x square by 2, 0 to 2. Next this 2 taking outside, that is 1 by 4 into bracket 2 square, substituting the limits 2 square minus 0. a0 is equals to 1 by 4, 2 square is 4. Here 4 get cancels, a0 is equals to 1. Next, an is equals to 1 by L integration 0 to L f of x into cos n pi x upon 2 into dx. 1 by 2, L is equals to 1 by 2 integration 0 to 2 x into cos n pi x upon 2 into dx. Here you can see product form is there, applying the Bernoulli's rule. 1 by 2 into x into cos n pi x upon 2, integration of cos n pi x upon 2 is sin n pi x upon 2 upon n pi by 2 minus u dash, that is derivative of x is 1. 1 upon n pi by 2 keeping constant, this 1 upon n pi by 2 keeping constant, integration of sin n pi x upon 2 minus cos n pi x upon 2 upon n pi by 2 between the limits 0 to 2. 1 by 2 into bracket, here this n pi by 2 goes to the numerator, that is 2 by n pi x into sin n pi x upon 2 minus into minus plus cos n pi x upon 2 upon n square pi square by 4 between the limits 0 to 2. Since sin n pi is equals to 0, sin 0 is equals to 0, this first term vanishes. We have only second term. In the second term, this n square by 4 goes to the numerator. 1, that is 1 by 2 into bracket 4 upon n square by square into cos n pi x upon 2 between the limits 0 to 2. This 2, here 4 cancels. We have 2 upon n square by square into bracket cos n pi 2 upon 2 minus cos of n pi into 0, substituting the limits. Here 2 cancels, we have cos n pi, that is 2 upon n square pi square into bracket cos n pi minus cos 0 is 1. 2 upon n square pi square into bracket minus 1 raised to n. Minus 1 raised to n means cos n pi is minus 1 raised to n minus 1. Next taking minus common from here, minus 2 upon n square pi square into bracket 1 minus of minus 1 raised to n. Next minus 2 Here I am substituting 1 minus of minus 1 raised to n value as 2. 1 minus of minus 1 raised to n is 0 if n is even. 1 minus of minus 1 raised to n is 2 if n is odd. Okay, using this one, I have substituted the value of this bracket term is 2. That is minus 2 upon n square pi square into 2, which is nothing but an is equals to minus 4 upon n square pi square. Here remember, we have taken n odd values. Okay. Next, bn. bn is equals to 1 by L integration 0 to L f of x into sin n pi x upon 2 into dx. That is 1 by 2 into integration of 0 to 2 x into sin n pi x upon 2 into dx. Here you can see it's a product form applying Bernoulli's rule. 1 by 2 into bracket x into integration of sin n pi x upon 2 is minus cos n pi x upon 2 upon n pi by 2 minus 1. 1 means derivative of x. 1 and keeping 1 upon n pi by 2 as constant. Cos of integration of cos n pi x by 2 is sin n pi x by 2 upon n pi by 2 between the limits 0 to 2. And here 2 pi by n pi by 2 goes to the numerator, that is minus 2 upon n pi into bracket x into cos n pi x upon 2 0 to 2. Since sin n pi is equals to 0, second term vanishes. Therefore we left with 1 by 2 into bracket minus 2 upon n pi into x cos n pi x upon 2 0 to 2. Again 2 cancels here. We have 1 minus 1 upon n pi into bracket 2 into this 2 here for x equals 2 into cos n pi 2 upon 2 minus 0. It becomes 0 because x equals to 0. We have to, the whole term becomes 0. The lower limit term becomes 0. Minus 1 upon, I just put it in a bracket, minus 1 upon n pi into bracket 2 into minus 1 raised to n. Because here 2 cancels, we have cos n pi. Cos n pi is minus 1 raised to n. Next is minus 1, I have put bracket because it should look like a minus 1 raised to 1. Minus 1 raised to 1, minus 1 raised to n, nothing but minus 1 raised to n plus 1. bn is equals to 2 into minus 1 raised to n plus 1 upon n pi. Hence, equation 1 becomes f of x equals to 1 by 2, substituting all the values, that is a0, an, pn, f of x equals to 1 by 2 plus summation n equals to 1 to infinity minus 4 upon n square pi square into cos of n pi x upon 2 plus summation n equals to 1 to infinity 2 into minus 1 raised to n plus 1 upon n pi. This is the required Fourier series.